Think math.
Pick 3 people out of 5 for cleaning duty. One student answered 60. Another answered 10. Wrong answers are ordinary enough, but the gap between these two is odd. It is exactly 6 times. An error that lands on a clean multiple is never a coincidence. It means only one thing went wrong. The student who said 60 counted 5 P3. They effectively built 3 labeled seats, first, second, third, and sat people in them. But cleaning duty has no first and no second. Whether A, B, and C get picked or C, B, and A get picked, it is the same 3 people. So that student counted one single group several times over. How many times? As many ways as 3 people can be lined up. 3 factorial, 6. What matters here is not the number 6 itself, but that every group is overcounted by the same 6. So the error does not wander from group to group. The whole total is inflated by one clean factor. Change how many you pick and the factor follows. Picking 2 gives twice, 3 gives 6 times, 4 gives 24 times. The error from mixing them up is always the factorial of how many you pick. That property is genuinely useful in an exam. When your answer disagrees with the key, look at how much it disagrees by. 6 times too large means you counted order in a 3-pick problem. Twice too large points at a 2-pick problem. And if your answer is 6 times too small, you needed the order and treated it as a combination instead. The size of the error tells you exactly where you slipped. So how do you avoid the mix-up in the first place? One question does it. Take 2 of the people you picked and swap their places. Does anything change? If they are president and vice president, swapping turns it into a completely different outcome. That is a permutation. If they are both on cleaning duty, swapping changes nothing at all. That is a combination. No problem is ever going to hand you the word permutation, so swapping them by hand is the surest test. Swap 2 of them. If it changes, permutation. If not, combination. A sip of math every day here at Think Math.